Hi, I'm Juuso Repo and I'm going to walk you through a tutorial on basic steps for reproducible workflow in R. The full tutorial is online on this website. This video will walk you through the main parts of it. So we're going to set up a project in RStudio. Then we're going to prepare and analyze data and generate some reproducible outputs. Then we're going to prepare code and data for sharing and finally share the code and data in public. We will start fresh in RStudio by creating a new project. File, new project, new directory, Guarto project. And we are not going to use Git or Ren in these basic steps. Create project. And next we will need to copy this script and then go to our RStudio console window and paste and run it. So what it does, it downloads the baby step notebook, which we can then open from here. So now we can follow the tutorial in our RStudio. And we're going to go to the first step. And we're going to run the code chunk. So the first code chunk runs some needed packages, and if you don't have them, it automatically installs the packages as well. Then we're just going to follow. And first we're going to create a project folder structure. So we want to have our files organized. And this is one way to do it. So you can just run this code chunk and it actually creates us the folder structure for our project. In this tutorial we will only use the three first folders: data, scripts and supplementary for sharing. The notebooks that we work on will actually be only for our personal use, and then we will extract the code from them for sharing. I will show you later how. Okay, that was the first step. The second step is to prepare and analyze data and generate outputs. We can run this code chunk next to download the simulate data notebook. Of course, you don't always start the project with simulating data, but I actually recommend it because it's a good way to plan before you have empirical data. So what it did, it actually added a notebook here, simulate data, which we now can open. So in simulating data notebook, we do two things. We first create a sample codebook, and then with the second code chunk, we simulate and save the raw data. So let's run them. Okay, first some packages again, and then the example notebook. And this code saves the codebook in a metadata folder, so it's under data and then metadata, and the codebook looks like that. So it lists the variables and the data structure. We don't need that anymore in here. Okay, the next code chunk then simulates our baby steps data, so we're gonna do some data analysis. Of course, we need some data, so this script just, you don't need to understand that fully, but it just makes us a data set and then writes it into our raw data folder. So we separate the raw data from processed data in our data folder. Then that's it, we can close the simulate data notebook and proceed with our tutorial. Okay, so next chunk downloads us the prepare data notebook. We can run the chunk here and then see that in our notebooks folder we have the prepare data notebook. And this is actually a template that you can use for preparing and planning your data processing. And maybe I'll show you online. So with this, so the same file here, it's preparing data. And you can see from this graph that we first load the raw data, then we modify data types, and then we do an initial EDA, so exploratory data analysis, to understand the structure of our data. And only after that we can start doing data cleaning, data transformations, and then run again the post-cleaning EDA before saving the processed data. Okay, back to RStudio. We are loading the raw data. So this is how we separate the raw data from the processed data. We will never touch the raw data, and this file has all the steps that we play and do to process the data. So we can first look at the structure of the data set with this code here, and we can see that there are 8 variables and 300 observations. Then we can convert the data types, so this code just converts the characters to factors, and then do the initial EDA. So what this Data Explorer package does, it creates automatic report which we can then use to understand our data better. Of course, there are many ways to do it, but this is just to give you an example that you can automatize some of those processes. Okay, now it's done. We can open it in not in the editor, sorry, but in the browser, right? So this is what the EDA report looks like. We can see the structure of our data, missing data analysis, distributions, and ggplots, and then correlation, stuff like that. All right. So back to RStudio, and then the data processing part. So we will not do much data cleaning here in this, and not correcting errors, not handling outliers, but we will standardize the variable names. So we want all of them to be lowercase. So we run this chunk, this row actually, to get lowercase variable names. Then data recoding transformations. What we do is there's something we do here. We transform the wave into integer, and then we will create another categorical variable. Then we could normalize the scales, create dummy variables, and when we are done, we can run the post-cleaning EDA. So the same report again, but now we could see that whether the data is ready for analysis. And when it's ready, we can run the save processed data chunk, which writes the processed data into CSV format. And that's it with preparing the data. Okay, before jumping into analysis, a quick reminder of our workflow. So it's important to understand that these files and folders support us in separating the steps here. So we simulate the data, we skip the collection part here, but then we process the data and all the steps which are needed for that. And then after saving the data, we can start analyzing, generating outputs like tables and figures, which they will be reproducible, and then we can export them to our manuscript or presentation. So you might write the full manuscript in RStudio, but it's a bit more advanced. We are not covering it here. We go back to our RStudio and we are on the step creating analysis tables and figures. We will run this chunk to download the next notebook, which is for creating tables and figures, and we will open it from here. So there are of course multiple ways of creating tables and figures. This is just to show you some examples and get the idea of the workflow. So there are tables and figures to be created here, and we start with loading the packages. The most important here is the model summary package, which automates table creation, and then the flex table package, which help us to customize and export the tables so that they are really they can be really edited in RStudio to be reproducible. These chunks also load our processed data and then adjust some variable types and rename some columns for better output. Okay, the model summary package. First, we will use the data summary skim function to just quickly look at the structure of our data. Okay. And then we can continue to creating a full table. So we will first set the flex table default, so to follow the APA guidelines or whatever guidelines we want to follow, so that all our tables will have the same style. And then we will run the data summary function to build the table. So the left side defines the rows, and then the right side defines the columns. And then we output it directly as a flex table. Then we can add a header. This is a flex table functions: align, add footer, set caption, and set header labels. And then we can preview so the table is now an object, and with this code we can preview how it looks like. Okay, so that's a flex table object, which we can then export to different formats. So the next code chunk demonstrates different exports, so we can save it to RTF or doc for Microsoft Word, PowerPoint, HTML, or an image file. And actually when I ran this, what happened, it came into our output folder, and we have the tables here in different formats. So I could show you, for example, the table in the Word file. It looks like this. Okay. So, and then the next table 2, we run some linear regression, and then we use the Broom package to create a tidy table, and then again the flex table package to customize the table in the same way that we did before. And here is just like the example of a descriptive statistics table for comparing groups at the baseline level in their baby steps style. Okay, third example, mixed effect model. So the model summary function again actually can handle mixed effect models as well. So we run here 3 different models, and then we combine the models into a list, and then put them in one put the results in one table. So the model summary function again creates us quite quickly a full table, which we can then, as it's now flex table format as well, so we can then save in different formats. Here we are saving one for our manuscript, and then we are building another a bit more colorful table for our PowerPoint presentation and saving it to a different file. So here you can see that there are, so I can preview the HTML table here is what it looks like. So we have the three models comparison there. And then two figures. So based on the same mixed effect models, we build a coefficient plot with the function model plot. So this is again from the model summary package. It creates like a ggplot object, so we can adjust it like we would another whatever like ggplot object, and then we can save it into a file. And I will preview the plot here, and it also is now saved in our figures folder. So we have figures folder separately and tables separately. Okay, then another thing is a report package for automatic reports. So this is a package which can create narrative reports based on models and also tables. So it's a bit different from model summary. So let's see, model. We are going to build a narrative report of the linear regression that we did. So this is the output. We fitted a linear model. It lists it in an APA format, and then we run a report table function for another window, and this is a bit like model summary, so it creates a table almost ready to work with. And then the same with mixed effect models, so it can also work with them, and it builds again a narrative report. So we fitted a model and then the effect sizes and confidence intervals, and then the same way a results table that we could work with flex table again to modify it for our final output. Okay, that's about it with creating tables and figures. We will go back to the main baby steps notebook, and now we are forwarding into step 3, preparing data and code for sharing. So what we do with the code, of course, we will have to write it in a way that somebody else will understand. So we can comment the code, we can create README files for more complicated analysis, we can study the style guide so that we can follow the best practices, for example in naming the objects, and then we can document the R version and packages used. So there is no dependency management in this tutorial, but this is like a short version for it. So we again using the report function. With this simple line we can actually create a list of our R packages used and the versions and also references. So this is a short version of it, and this line saves actually a text file into supplementary material so that there is a longer version of our dependencies. So somebody can then recreate the computational environment that we used within our RStudio. So that's about preparing the code. And when you are satisfied how the code looks, then comes the part when you can extract the code from the notebook. So we work with notebooks because we can see the results at the same file, and we can also write our own personal notes there. So how I work with them, I will not put the notebooks in the final manuscript attachment or so, but I will extract the scripts from the notebook. So this pour function takes one notebook at a time and outputs it into an R script file, and that will be the one that we will share in public. And the trick is that we have put for all of our code chunks, we have actually labeled them. So with our code chunks, we label them in the first row, and then we decide whether we include them in the script or not. So for example, here we set Perl false because this is a chunk which just prints the skim summary of the file. So we don't need this in the final script that we are going to share with our manuscript. So these chunks that we use for exploratory analysis or something else, we will put the Perl false there, so that when we run the Perl command in our main notebook, we can now go to see how it looks like. So again, in our now in our scripts folder, we have the notebooks extracted as script files. So we can look, for example, the prepare data, R script, and this is ready for sharing. It tells that we are loading the data, and then it has the sections for all the data processing steps that we have made. So when we are happy with our script files, of course it's a good idea to test them before sharing. So we could start a new R session just to make it fresh, and then run this chunk which actually runs all the 3 scripts that we created. So we had 3 notebooks, we created 3 scripts based on them, which has all the code from the notebooks, and now this chunk actually runs our full workflow from the start. And if we change something in data processing, we can come here and run only the last row, for example, to create new tables and figures. So they are now replaced the old versions in our folders. So let's go to sharing. First of all, the notebooks are nice and good for sharing with the colleagues. So they can of course use them in RStudio if you just share the notebook file like I did with you, but you can also render them for HTML. So I will show you an example. We will render the prepare data notebook. So we open that, and then the output can be anything like PDF or even a Word file, but this time we render it for HTML. So we just push the render button, and it runs the code again, and it creates like a HTML file based on the notebook. So this is something that you can share with somebody who is a non-coder. So it has your notes, and it has the code chunks, and it has the results from the code chunks. So the full content of the notebook is something that you can share with your colleagues, or online with your project web page. But then for public sharing, you should always, of course, for full reproducibility, to share your raw data when that is possible. And of course you need to think the consent, the format, documentation, and the de-identifying issues before sharing your data. But once your data is ready to be shared and the code is ready to be shared, you can just decide what is the forum where you will upload those. So, for example, Open Science Framework osf.io is one example that I have been using, and it's quite popular in social and behavioral sciences. So what we would share is actually, like I said, only the first three folders. So we would create a repository in OSF, create the same 3 folders, and then upload our raw data, not the processed data, but the raw data and metadata, and then the scripts, and then the supplementary material. So we had the code, in supplementary we had the dependencies, yes, there. Okay, that's it. We followed a basic workflow for reproducibility. I hope you got some ideas, maybe templates that you can adjust, modify for your own needs and style, because of course there are many ways to do these things. You can find the most updated version of the tutorial online. I will be updating it based on the feedback. Thanks for watching.